A long time ago in a galaxy far, far away. That's how the iconic Star Wars intro begins one of the greatest science fiction films in history. But today, that galaxy once imagined in fiction is becoming increasingly real. Humanity is making incredible progress in space exploration. We've sent probes to Mars, built telescopes capable of peering to the edge of the universe, and we're planning missions to return to the moon and venture even farther, perhaps to Mars, and one day, to the stars. Guys, welcome back to my channel. Today we talk about something very interesting. Welcome to my new format dedicated to space. You are ready to discover the secrets of space together.
All free men, wherever they may live, are citizens of Berlin. And therefore, as a free man, I take pride in the word. In an hour of change and challenge, in a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. No man can fully grasp how far.
But how much do we truly know about our galaxy? The Milky Way contains an estimated 100 to 400 billion stars and could hold billions of potentially habitable planets. Yet, despite all our technology, we've explored only a tiny fraction of it. Here are some fascinating facts. At the center of our galaxy lies a supermassive black hole called Sagittarius. As some stars travel at millions of kilometers per hour. There are exoplanets where it might rain iron or glass, or where one day lasts an entire year. The future of humanity might truly lie among the stars. What was once science fiction may very well become tomorrow's reality. Today we'll try to answer a fundamental question: what is a galaxy? We'll explore how galaxies were born, what shape they had in their early stages, and how they evolved over time. In truth, rather than offering definitive answers, I'll raise doubts and reflections because the history of galaxies is long, fascinating, and deeply complex. In recent years, thanks to increasingly powerful and advanced instruments such as the James Webb Space Telescope, we've had to rethink much of what we thought we knew about early galaxies. We expected them to be small, chaotic, and irregular, but surprisingly, many appear already mature and well-formed, even in the first few billion years after the Big Bang. These discoveries raise new questions. Did galaxies form faster than we thought? Or do we need to update our models of the universe's evolution? Galaxies are not just clusters of stars and gas, they are true cosmic ecosystems, each with a unique history filled with mergers, stellar explosions, and mysterious gravitational interactions. And the further we look into space, and thus back in time, the more we realize how much we still have to learn. The arrival of the James Webb Space Telescope marked the spiritual successor to the legendary Hubble Space Telescope. But our story actually begins with Hubble back in 2016, when astronomers discovered a galaxy called GNZ11 at the time, the most distant galaxy ever observed, with a confirmed black hole at its center. It appeared as a small, faint reddish blur, barely distinguishable. But why was it reddish? And how could it be so large, given its place in the early universe? The reddish color comes from cosmic redshift, the stretching of light to longer, redder wavelengths due to the expansion of the universe. Its surprising size challenged expectations. Astronomers thought galaxies from that era would be small and chaotic, yet GNZ11 already appeared quite massive and structured. So what actually happens when we look at the cosmos? Let's imagine ourselves as cosmic archaeologists for a moment. Because the farther away an object is from us, the earlier its light began its journey. So when we look at something extremely, incredibly distant, what we're really seeing is something extremely, incredibly old. We're kind of like the Indiana Joneses of the universe, and honestly, that sounds way cooler than social misfits staring at the sky, don't you think? In our role as galactic adventurers, we discovered GNZ11, a tiny galaxy compared to the Milky Way, only about 1/20th of its diameter and just 1% of its total mass. Yet despite its small size and youth, It was already surprisingly well structured, a cosmic mystery that makes us question how, and how quickly, the first galaxies came into being. This galaxy, GN-Z11, formed just 400 million years after the Big Bang, and based on what we know today, that's something incredibly hard to grasp. The first stars in the universe began forming around 100 to 180 million years after the Big Bang, so if you think about it, in just about twice that time, roughly 200 million years more, a fully structured galaxy had already emerged with stars, dust, and possibly even forming planets. It's the kind of thing that still surprises and unsettles astronomers. How did the universe manage to build something so complex, so quickly? And that's not all. GNZ11 also had a very high star formation rate. It was creating new stars at an astonishing pace, especially compared to other galaxies of its time. A true stellar factory, far more active than average. Now that galaxy, GN-Z11, had a star formation rate about 20 times higher than our Milky Way. It was a new, active, and dare we say, beautiful galaxy. Not exactly a cosmic newborn, but still fresh on the scene, a sort of Sputnik of the early universe, small, fast, and already fully operational. The fact that something so structured existed just 400 million years after the Big Bang definitely shook us up a bit. But all in all, scientists were able to stretch and adapt our galaxy formation theories to fit this unexpected discovery, but that was 2016. Then came 2024, and with it, the James Webb Space Telescope, which changed everything. Webb's observations revealed galaxies that were even older, larger, and more evolved than what our models said should be possible at that point in cosmic history. So GNZ11, which once seemed like an odd outlier, suddenly became just the beginning of a much deeper mystery. But even before the arrival of the James Webb Space Telescope, we already suspected that there was much more to discover in the depths of the universe. However, it was James Webb that truly changed the game, thanks to its remarkable ability to peer deeper into the cosmos than any telescope before it. One of Webb's greatest strengths is that it doesn't observe invisible light, like Hubble. It sees in the infrared. This allows it not only to cut through clouds of gas and cosmic dust, but also to detect much older and more distant objects whose light has been stretched into the infrared by the expansion of the universe. And there's more. James Webb can take advantage of natural cosmic phenomena, such as gravitational lensing. Massive structures like galaxy clusters can act as giant magnifying glasses, bending and amplifying the light of objects behind them, allowing us to see even farther back in time. Thanks to these capabilities, James Webb has opened a whole new window into the early universe, revolutionizing our understanding of the cosmic past. Sama, but before we dive into James Webb's revolutionary discoveries, let's open a quick parenthesis. Have you ever noticed that almost every newly discovered galaxy has a Z followed by a number in its name, like GNZ11? That little Z isn't just a random letter, it stands for a key concept in cosmology, redshift. So what does that actually mean? Redshift happens because the universe is expanding. As light travels through space, it stretches, shifting toward the red end of the spectrum. So the higher the redshift value, Z, the farther away the galaxy is, and the older it is too. In essence, we're literally looking back in time. For example, GNZ11 has a redshift of Z equals 11. That means its light has traveled for over 13 billion years, and we're seeing it as it was just 400 million years after the Big Bang. So next time you see names like Z10, Z12, or Z13, know that it's not just some technical code. It's actually a timestamp of the universe telling us how far back in cosmic history we're peering. When we talk about redshift, we're actually referring to a physical phenomenon called the relativistic Doppler effect. To understand it better, let's draw a comparison with something most of us are familiar with: the normal Doppler effect. Have you ever heard the sound of an ambulance approaching? As the siren comes closer, the sound of it changes, right? When the ambulance is coming toward you, the sound seems higher pitched, while if it's moving away, the sound becomes lower pitched. This is the Doppler effect applied to sound waves. Now, imagine what happens in space. When a galaxy moves away from us, its light gets stretched toward the red end of the spectrum, just like the ambulance siren shifts in pitch. This is a similar effect, but applied to light instead of sound. However, in the case of the cosmos, we're talking about a relativistic effect because it concerns objects moving at very high speeds, close to the speed of light. The farther a galaxy is, the more its light shifts to the red, indicating it's moving away from us. And this isn't just a small shift, it's a true time marker that allows us to look back into the cosmic past. Small note: if you ever hear a siren from a distance and can't tell which way it's coming from, don't jump into a ditch. The Doppler effect is also useful in daily life to help us gauge the direction of moving objects.
So that's the Doppler effect. The relativistic Doppler effect is very similar, but instead of sound waves, it deals with light waves. Think of it as a distortion of light emitted by a source, whether it's a lamp, a star, or a galaxy, that is either moving toward you or away from you. If the object is moving toward you, the light is compressed and shifts toward the blue end of the spectrum. This is called blue shift. If the object is moving away, the light is stretched and shifts toward the red. That's the well-known red shift. Now here's the fascinating part. The universe is expanding. That means the farther away a galaxy is, the faster it's moving away from us. And the faster it moves away, the more its light is red shifted. So redshift doesn't just tell us how fast something is moving, it also tells us how far away it is and how long ago the light was emitted. It's like having a ruler and a time machine in one. Thanks to this effect, we can map the structure of the universe, estimate the age of the light we see, and essentially look back into the cosmic past. The farther a galaxy is from us, the higher its redshift will be, and that value doesn't just tell us that the galaxy is moving away, it also gives us a measure of how far it is and how old the light is that we're seeing. In other words, the higher the z value, the farther away the galaxy is, the older its light is, and the faster it's moving away from us. So whenever we read a name like Z11 or Z13, we should remember that this number is far more than just a technical detail. It's a window into the early universe telling us where the galaxy is, how long ago it emitted its light, and how fast it's receding.
Then came the James Webb Space Telescope, and in May 2024, it confirmed the existence of a galaxy called JADES GSZ140. Not exactly the catchiest name, I know. But what does this mean? It means that this galaxy formed just 290 million years after the Big Bang, which makes it the most distant and earliest galaxy we've ever observed. For comparison, the previous record holder, GNZ11, formed about 400 million years after the Big Bang. So with JADES GSZ140, we're looking 110 million years further back in time. And even though the light from this galaxy has been traveling for 13.5 billion years to reach us, the universe has been expanding in the meantime, kind of like a rising panettone with the candied fruits, galaxies, moving farther apart. Because of this expansion, the actual current distance between us and JADES GSZ140 is not 13.5 billion light years, but roughly 33.5 billion light years.
At the time JADES GSZ140 formed, the universe was less than 2% of its current volume. Since then, it has expanded dramatically, which explains why the distance between us and this galaxy, once much closer, has grown to 33.5 billion light-years today. But what's even more astonishing about JADES GSZ140 isn't just that it's much younger than GNZ11, it's also much smaller, roughly 1/60th the size of the Milky Way, and yet it's rich in oxygen. That's what really puzzles astronomers. The presence of heavy elements like oxygen in such an early epoch of the universe suggests that first-generation stars must have already formed, exploded, and enriched the galaxy's gas in an unexpectedly short time.
Oxygen is a chemical element that, like all heavier elements in the universe, is formed inside stars. It all starts with hydrogen, then comes helium, carbon, and eventually oxygen. In short, producing oxygen takes time. It requires stars to be born, live their lives, and then die in supernova to release those elements into space. So, if we detect oxygen in a galaxy, it means that stars have already been born and died within it, and that changes everything. JADES GSZ140 is not a newborn galaxy, but one that already has a stellar history, even though it existed in one of the earliest eras of the universe.
We're observing a galaxy JADES Z140 that emitted its light just 290 million years after the Big Bang. On a cosmic scale, that's the blink of an eye. And yet, the galaxy was already remarkably evolved, with stars that had already been born and died, enriching it with heavy elements like oxygen. This discovery has deeply challenged the standard models of galaxy formation, which did not expect such rapid development in the early universe. But that wasn't the last surprise. Also, in 2024, the James Webb Space Telescope detected 5 new objects over the course of just 5 weeks. These are likely very early galaxies. Although they have not yet been confirmed and do not have official names, scientists are currently analyzing the data to learn more about them. But these 5 objects observed by the James Webb Space Telescope are located over 34 billion light-years away from us, and they emitted their light just 200 million years after the Big Bang. For comparison, JADES Z140 dates back to about 290 million years after the Big Bang. I've included a reference table below to help keep track of everything. Now, we're observing galaxies from as early as 200 million years after the universe began, with redshifts between 16 and 18, even higher than that of JADES Z140. And despite being so ancient, these galaxies already appear structured, almost mature. In short, it's very likely that the James Webb Space Telescope will continue to surprise us, pushing the boundaries of how far back in time we can see.
The James Webb Space Telescope is getting better and better at taking advantage of these cosmic phenomena, and it might do even more in the future. We could truly discover galaxies that are even farther away, both in space and in time. Just a quick final note. Maybe next time we can talk about what we really know about the expansion of the universe, because there are some surprising things there too. And one last thing. When I say we, it's to include you in this journey. I'm a space engineer, but these videos are meant to inform, spark curiosity, and share the wonder of the universe with everyone. Guys, if you want to know more, see you in the next video where we'll talk about space and SpaceX. Catch you in a galaxy far, far away.